Hello everyone, so in this video, let us talk about a medium level problem from Leetcode, and as you can see that it is highly rated, it is very much liked by different folks as well. So let us try to solve this problem out. The problem name is rotting oranges. So the problem statement states that you are given an M cross N grid where each cell has one of the three values. The grid is such that if it has 0, it represents an empty cell. If it has 1, it represents a fresh orange. And if it has a 2, it represents a rotten orange. Now, every minute, any fresh orange that is four directionally adjacent to a rotten orange becomes rotten. Okay, it's just like some disease spreading. Okay, if a fresh orange is adjacent to a rotten orange, the rotten orange will, let's say, spread its disease to the fresh orange and it will also become rotten orange. So this process will keep on happening. Return the minimum number of minutes that have to elapse, that has to pass, until no cell has a fresh orange in that. If it is impossible, then the answer is -1. That's the whole problem statement. That you just assume that there is some rotten oranges. Let's say these are crossed by this, and there's some fresh oranges. Now the rotten oranges will spread its disease in all the four directions in every second. So let's just take this example that this is the rotten orange. It will spread its disease in all directions. This direction, this direction, this is out of bound. So these two will also become, you can say, rotten in the next second after minute equal to 1. Okay, this is 1 minute after. So these three now become rotten. So now these three will eventually transfer their, let's say, disease to all the recent ones. So this will transfer to this. This is already rotten, so it will not affect this. There is no upper one, this one lower one. This will again transfer to this. Again, all the four directions, you can just assume. Now in this direction, only this is in contact and this is in contact. So these two will again become rotten in the next minute. Now this will again transfer in this direction, this direction, this direction, and this direction. So these two are already like infected, so they will not like infected again. So this will, the only fresh one will get infected. So this will get infected in the next minute, and the next minute this will get infected because it is adjacent to that. So after 4 seconds, all the, you can say, oranges will get infected. Now, what is the case in which like you cannot reach that? Let's assume there is a grid like this, and the good one is here, and the rotten one is here. Okay, there is no addition to that, let's assume. So in this scenario, you cannot directly reach this orange in any case possible, because there is no, you can say, passage to transfer through to this particular orange, and thus the answer for this is -1. That's the whole problem statement. Now how can we solve out this problem? The overall idea which boils down to here is that, like, every, you can say, every rotten orange transferred to all its adjacent four directions. So it is transferring in a BFS manner, breadth first search, like every layer one by one. But now there might be multiple oranges. What I mean by this is that if I have only one source, BFS means that I have this source, it will transfer in all the four directions. Then it will keep on transferring, like from this direction it will go to this direction. So every element do a BFS around it. But because there are multiple sources, which means that now if this become rotten, this also become a source, because now again this also, you can say, start infecting. Also, not only this, let's assume that there is one infected here and there is one infected here. Let's assume in the starting state there is one rotten here and one rotten here. So what will happen in that in 1 second this will infect this and this, and in the 1 second this will infect this and this. I hope you understand, because like they are continuously infecting the adjacent fresh oranges. In that scenario, there are multiple starting points, not only one starting point for the BFS. And thus, this is a problem which turns out to be multi-source BFS, multi-source BFS. Now, how this multi-source BFS is different from a single source BFS? In a single source BFS, what we eventually do, we make a queue in which we'll start the queue with the very first element from which we want to do our BFS with. Let's say the starting point. And then from the starting point, whatever point it touches, we will take out this point from the, you can say, from the BFS queue, and insert all the other elements that are adjacent to it. But now in this scenario, because everyone is the starting, which are rotten, we will insert all of these one by one, which means that from this, because everything is elapsing 1 second by 1 second at a time, so I will insert all the starting one in the queue in the start. In the single source, we will initialize with a very single starting node or single starting point, but in this we will initialize the queue with all the starting nodes. and so on. And then we just do the BFS as it is, that we do, and this will be sufficient to solve this problem. Nothing much complicated. Now you have to also store out the number of time elapsed to, like, after which this whole oranges will get infected. So you can have created a visited matrix for that, which will help us to know that, let's say this is infected, so we mark it as 1, that this is already infected. Now to infect all the adjacent ones, I will mark the adjacent one to take a time of 2. So when I'm doing BFS, I will mark all the adjacent one of this rotten one as 2. Now after this rotten one is done, all the adjacent one of this rotten one will be marked as 3. So as I'm doing the BFS, as I'm moving towards the next layer of BFS, because it's a layer wise traversal, you can say BFS is just a layer wise traversal. So as we move to the next layer, we will take the previous layer values and just add 1 to it, so that it just means that I'm adding 1 to the time. Okay, so this is how we will travel to, and whatever is the last value, because I'm starting it with 1, the last value will become equal to, as you can see, that this will turn out to be 4, this will turn out to be 5. This will turn out to be 5 eventually, but the answer is 4 because I've started with 1. Okay, if you want to start with 0, then you have to initialize the complete matrix with -1. And if you initialize the complete matrix with 0, you can initialize with 1, and in the end you subtract it by 1. It totally depends upon you how you will try to formulate your initial starting widget matrix. Okay, because you have to store all of these values 1, 2, 3, 4, 5, so on. As you travel over this whole, you can say oranges grid, and if the grid is already infected, okay, you will not infect it again because it is already infected. Okay, and in the end, when you have done all your whole process, you will again iterate over the whole matrix, find out the very maximum value, because that's the very maximum time to take into elapse or to infect all the oranges. If you find out any orange that is still not infected, then the answer is -1 because you have not been able to infect all the oranges. If you are able to infect all the oranges, then you just have to find out the maximum among all the values present inside the visited matrix that you have been creating to store out which time has been used to infect all the oranges. That's the overall problem statement and the logic for this particular problem. It will make more clear to you as we go through the code, because that is more easy to understand as well. So this is the starting part. This is the function that has the grid. So what we'll do is that we'll make a queue in which we'll do our BFS. Then we'll make a direction array, because from every point you have to go in all the 4 directions. So you can make a direction, you can say vector, which is helping us to move in all the 4 directions. It will be shown later in the code. Then these are the you can say dimensions of the grid which we have, which are given to us. Now we have initialized a visited matrix, which I've told you, of dimension n cross m. Everything is initialized to 0. Okay, then what we'll do, we will iterate over this whole grid, whatever grid that is given to us. And what we'll do is that we know that the ones that are infected are marked as 2. The ones which are fresh are marked as 1. And if there is no orange, then it is marked as 0. So, which I've told you, it's a multi-source BFS. So I have to know what all oranges are infected, because those start as a starting point of the BFS. So I will iterate over this complete grid, and whatever is marked as 2, I will push it inside this queue with this particular index, at what index that particular orange is that infected, and mark it as 1 in the visit matrix, that these are the infected ones. I'll start from here. This is the starting point of the BFS, and it will take, like, let's say, like 1. 1 is the starting point in the visit matrix. Now eventually what we'll do next, we will start our BFS here. So we will do our BFS here. Let's talk about that. This is the BFS part. Okay, so how we do BFS? We will do complete BFS until the queue becomes empty. We'll pop out the first element from the queue, pop it out, and then iterate over all the 4 directions for the particular element that we have iterated over. So if the current direct point I'm on is X, then we will add all the 4 directions one by one. That's why the direction vector is important. Iterate over all the directions, left, right, top, bottom, and calculate the new, like, let's say, new block you want to go to. So let's say if I'm on 0, 0, I'll go to the left, right, top, bottom. So we'll get the, let's say, coordinates, or let's say block index of all of them one by one. That is capital X and capital Y. Now to iterate over or to go to that particular block, I have to ensure that that should be inbound. So this OK function will just tell me that whether X and Y that I've calculated out to go in that particular direction from the current block I am on, is it in, like whether it is valid, it is inbound. So that is OK function. Then I will only go to that block if it is not visited, which means that it is not already infected. If it is already infected, it's ways to go to that point. Okay. So if it is not infected, then what will happen in the visited matrix? It is 0 because I've initialized everything in the visited matrix as 0, which means that I've not iterated over that. And we will only go to that point if it is a fresh orange. If it is a empty block, I will not go to that particular block because there is nothing there. So these three conditions are valid, that it should be inbound, it should not be already visited, and that should be a fresh orange. If all these conditions are met, what we'll do, we will mark that next orange, because I'm moving to the next layer now, as the previous layer value, that is this, plus 1. So this is the next layer value, that is capital X, capital Y. That should be equal to the previous layer value, that is this, plus 1. Okay, so that I'm going to the next layer, 1 minute added, and now add this new rotten orange in the hue, because now it has become rotten and it will start its own BFS and it will do continuously, like you can say, infect the other fresh oranges. That is how the complete BFS runs, and it will infect all the oranges. In the end, what we'll do, we just have to check out that whether there exists a orange that is left, and if it is not left, what is the maximum amount of time that is taken to elapse all the oranges. So we'll iterate over again the visited matrix and check out that if I find out any orange that is not visited, that it is equal to 0, and it is a fresh orange, which means that I found a fresh orange that is not visited in the matrix, then the answer is -1. And if we do not find out such condition, I want to maximize over all the values present inside the visited matrix, because that shows us what is the maximum time taken to infect the very last orange, that is the farthest away. Okay, in the end, I've told you that the answer is answer -1 because I've initialized everything with 1. Okay, that's why like this start with 1, so that in the end it turns out to be 5. Answer is 4 because I've initialized with 1. I have marked that this is infected at time equal to 1, but this is already infected, so it should be time equal to 0. But I have like done in this particular convention, so answer is answer -1. If you start everything with -1, then you could have got the answer in which you have already got the answer. But yeah, particularly depending upon your convention, how you're going to solve this particular problem. That's it. That's the problem statement and the logic for this particular problem. Coming now to the time complexity. As we can see that we have done multiple for loops. So we have done a nested for loop that is just O of m cross n. This is a complete while loop that is again O of m cross n. This is again a while loop O of m cross n. So total time complexity turns out to be O of m cross n only. Okay, because we're again and again iterating over the complete matrix only, nothing much that is there that we have done, and because they are individual for loops. And that's it. That's the logic and the code part for this particular problem as well. If you still have any doubts, you can mention down in the comment box of this particular video. I will see you in an excellent day coding, and bye.